Okay, so here we go. So I want to talk about this first, standard form. We started on this yesterday. Standard form is when the x's and the y's are on the left, just like this. Okay? And the constant is on the right. The constant is a plane number. All right, notice that the x's have to go first, the y's have to go second. We also made the stipulation that A, B, and C must be integers. And remember, an integer means no fractions and no decimals. No fractions and no decimals. All right, is everybody okay? Okay, so here's the first problem we're going to work. I want you to put this in standard form for me, okay? 3y minus 2 equals 7x. I want you to take that equation and put it in standard form. Okay, do you have it? All right, so I'm going to say most of you took this 7x. When you pull it over here, what does it become? Negative 7x. We're going to leave the 3y on that side so he stays positive. All right, and then equals, when you pull this negative 2 on this side, you're really adding 2, guys. You can't pull stuff across the equal sign, but that's what it looks like you do. You pull it to the other side and it changes its sign. But you're really adding 2 over here and it goes away, and you add 2 over here. So you end up with a positive 2. Okay? Does everybody understand? Okay. Yes? Everybody okay? All right. So I'm going to say this. Used to be a long time ago, this was not an acceptable answer. When I was in school, our teacher would have never counted this right. Because they said you could not have, A could not be a negative. All right? So some, pardon me, some teachers and some testing banks, I'm specifically talking about the SAT and ACT, might not have this as a negative. This might not be their answer. Their answer, they don't want this as a negative, so how are they going to write this equation? Positive 7x, what? Minus 3y is equal to negative 2. They're just going to change everybody's sign. So if you get this and then you don't see that in your answer bank, maybe it's a multiple choice question like on the SAT or something, then notice that this is the same thing as that. They just divided everything by negative 1. Okay? I'm okay with this, and some books are okay with this. Some books are not okay with it. So you just need to know what your teacher expects of you. I don't mind it. If they, the book that we teach out of, it says it's okay. But I do always tell my kids, because sometimes, especially on an SAT or an ACT test, they will not put that negative term first. Okay, so they'll change all the signs. All right, so let's do another one. Are you ready? B. 2/3 x plus 4y is equal to 1/2. 2/3 x plus 4y is equal to 1/2. So we want to put this in standard form. Well, I like the way it has all the x's first and the y. Those are both on the left. My constant or my plane number is on the right. So what's the problem with this guy?
They're not your fractions.
Okay, yeah, you can't have fractions, all right? Y'all, what are the numbers? There are 2 numbers up there that are making it difficult. They're my problems. What are those 2 numbers?
2/3 and 1/2.
More specifically, it's actually just the 3 and the 2. Do you agree with that? If I didn't have a denominator, would I have a fraction? No. Okay, so I'm not really concerned about the numerator because I don't care what it is. What I do care is I need to get rid of this guy right here. Okay, so what I'm going to do is look at all my denominators. In this case, it's only 3 and 2. And I want the least common multiple between 3 and 2.
6.
Very good. It's also what your brain might call the least common denominator, but I'm gonna multiply everything by 6. Now I'm gonna tell you where the mistake's gonna happen, okay? So, we're gonna multiply this first guy by 6. Remember how we talked about doing this? That this line means divide, so you're gonna divide by the bottom number, multiply by the top. How many times does 3 go into 6?
2.
And what is 2 times 2?
4.
So this is 4x. Are you with me?
Mm-hmm.
Okay, so where's my mistake gonna happen?
Okay, we're gonna multiply it by 6.
That's exactly right. And there's 2 reasons that kids forget this. First of all, they forget to distribute. And second of all, some kids will go, oh, well, I don't need to multiply him by 6 because he's not a fraction. Y'all, that's not fair. You can't like pick who you want to multiply. You have to multiply everybody by it. So when you say 6 times 4y, you get perfect. And what's half of 6? 3. So this is the equation. Y'all, if you graph this equation or this equation, they would be the same thing. Okay? They are equivalent to each other. All right, one last one. This is the last one we're going to do, putting in standard form. He looks like this. 4.1x plus 7.28y is equal to 25. Okay? I got an x over here and a y, like that. Got a little plain number over here. So everything looks good. What's the problem? Okay, decimals. So you can't have decimals. They have to be integers. So what am I going to multiply by?
By
100. Why did you pick 100, Gunner?
because if you multiply it all by 100, it moves the decimal places 2 values, and it'll be 410x plus 728y equals 2,500.
Very good. Okay, so essentially this is what Gunner did. He looked at this and he said, what's the most number of digits behind the decimal point? This guy right there. I have 2 digits behind the decimal point. So that's how many zeros I have to have. I'm going to multiply by a multiple of 10. Okay? And I need 2 zeros, so that makes 100 because y'all, if you had 4 digits behind the decimal point, you would need 4 zeros. That would be 10,000. Do you understand? Mm-hmm. And once again, everybody gets multiplied by that. So all you're doing is moving your decimal point 2 places to the right because that's what happens. What's 100 times 4.1x?
410.
Okay. Plus, what's 100 times 7.28y?
728.
Equals, what's 100 times 25?
20,500.
Yeah, 2,500, 2,500. So there's my answer. Are those hard? No, those aren't difficult. So you're going to have some, you might have a problem that says put it in standard form. Okay, and if they do, then that's the form that it wants. Okay, so one last thing that we want to talk about, and then I'm going to let you work on either your homework if you haven't finished it, it's due tomorrow, or I'm going to let you work on practicing for your test, reviewing for your test. So X-Intercept. Okay, X-Intercept. What is the X-Intercept?
Where you intercept the x-axis.
Y equals 0.
Okay, so where your graph crosses the x-axis. That's called my x-intercept. Okay, now I'm going to draw you a little picture. Okay, here's a little coordinate plane, and I'm just going to slap a line on there. I don't care what kind of line it is. It doesn't make any difference. I could put it anywhere I wanted to. I just happen to pick right there. Okay, so does everybody see the x-intercept?
Yes.
You agree it's right here?
Mm-hmm.
Okay, so in order for this x-intercept to lie on the x-axis, what does y have to be?
0.
0. You can't go up any or you can't go down any. Okay, you just have to be stuck right there. So how do you find an x-intercept? Well, you're going to make y equals 0. And then you'll solve for x, and it'll tell you where it crosses the x-axis. Okay? Now, because sometimes you have to tell people things like 9 times to make it stick in their head, I'm going to tell you all the different words for an x-intercept. Okay? Some of them maybe you've heard before, maybe not. We're not really studying all of them, but I'm going to tell you what they are. So an X-intercept is the same thing as a zero. Sometimes in a problem, they'll say find the zeros. Those are the X-intercepts, okay? That's where that graph crosses that X-axis. Sometimes they're called roots, okay? If they say find the roots, those are the zeros, those are the X-intercepts. Sometimes they're called solutions or answers. So all those equations that your teacher made you solve for algebraically, I'm going to show you how, not today, but I'm going to show you how you can graph it and check your answer on the calculator, okay? Because where it crosses the x-axis is important. It's not always the easiest way to do it, but it is a way. Okay, so y-intercept. That's going to be where what?
The graph, there's the the y-axis.
Yeah, where your graph crosses the y-axis. Okay, and how, now look, here it is right here. Here's a picture of it. Okay, you know what they say, a picture's worth 1,000 words. Sometimes kids don't get the words, but you show them a picture and they're like, oh, that's what you're talking about. Okay, so in order for this point to be on that y-axis, can you go left or right, any? No. So how are you going to find it?
Make X equal.
There you go. Make x equal to 0. Okay, so essentially this is what it is and how you find it. I'm going to show you something pretty cool about it. So example 5. I'm going to give you an equation. 5x plus 2y is equal to 10. Now y'all listen to me. If you want to find an x-intercept, you plug 0 in for y and you solve for x. That will give it to you every time, okay? But when that equation is in, what's this called? What kind of form is this? Standard form. Then some really cool stuff happens and I can work my problem really fast. So let's find an x-intercept. Now when I'm looking for an x-intercept, what's my brain telling me to do? Yeah. So I'm going to go up here and I'm going to say, really what I'm doing is I'm plugging 0 in for y. Y equals 0. So I'm going to go up here to this equation and I'm going to plug 0 in for y. So I've got 5x. Are you with me? Plus, what is 2 times 0 is equal to 10. What is 2 times 0? 0. So this term goes away. Do you agree with that? And you're just left with 5x is equal to 10.
So x equals 10.
So x is what?
2.
2? If x is 2, if that's my, y'all look, I don't mind you writing it this way. I like it like this, okay? But some kids don't. Some kids want to write it as a point. Here's what I'm going to say. If you have this and you want to write it as a point, you're more than welcome to. I will grade it. But if you have this and you write the point wrong, I will take your points away. You got it? Okay. So if you wanted to write this as a point, what would it look like?
0,
2, 0. And that's what we're trying to be careful about. Okay?
So wait.
Because a common mistake is to flip that thing around and go 0, 2.
So we can just keep it as x equals
Yes.
2 and it's
Matter of
fine.
fact, on your worksheet, I put x equals y equals, x equals y equals. Because I was trying to help you not make that mistake. Okay? But some of the kids still wanted to write it this way. And I said, you're more than welcome to. But if you get this right and you mark it and you put this wrong, I'm going to cut your points off. Okay? All right. So let's do a y-intercept. What's my brain thinking on a y-intercept?
X equals 0.
Yeah. Make x equal 0. Okay, so sometimes kids do this. Sometimes kids get messed up and they're like, oh my gosh, I'm looking for the x-intercept. I can't remember what to do. Do I make x equals 0 or y equals 0? People, you're looking for an x-intercept. Obviously, it's not x equals 0. If you knew what it was, you wouldn't be looking for it. Do you understand that? Okay, so think about that when you run into that problem. All right, so I'm going to plug 0 in for x. So here, I'm going back to this equation. 5 times 0 plus 2y equals 10. Y'all said this is 0. So really, I just have 2y equals 10. And what is y? If you wanted to write it with a point, what would it look like?
0, 5.
Very good. 0, 5. Because y is 5, people. X is 0. All right? So, let me show you something cool about this, because this is very useful. I've showed you how to graph a line, do you agree?
Yes.
So this can be used to graph, how many points does it take to make a line?
2.
2. Through any 2 points, there is exactly 1 line, okay? So watch what's gonna happen. I can go over here and I can say, well, I wonder what look up here at my paper. I wonder what my X-Intercept is. If I want an X-Intercept, when I plug 0 in for Y, this term goes away. And I'm left with 5x equals 10. So what's my X-Intercept? 2. Okay, watch this. If I want an X-Intercept, I'm plugging 0 in for Y. When I plug 0, do you agree that this term goes away?
Yep.
And you're left with 5x equals 10. If you divide by 5, what's x?
2.
So that's my X-Intercept at 2. I'll make a big fat dot right there. Okay? I'm going to play the same game with my Y-intercept. I'm going to look for a Y-intercept. I'm going to plug 0 in for x. That guy's going away. 2y equals 10. What does y have to be? 5. So I'm going to count up on my y-axis. 1, 2, 3, 4, 5. There's my line, people. Was that easy?
Yes.
Did I have to solve for y?
No.
Could you solve for y and get the same line? Yes, you could. But this is very easy. Okay? It only works like that when it's in standard form. Alright? But when it is in standard form, a lot of people will graph it this way. Just because it's easier. Okay, so the last thing I want to tell you is just about your test. Okay? So tomorrow your test is on 1.7 and 2.1 through 2.3. You agree? Oh, sorry, you can't see it. 1.7, 2.1 through 2.3. This 1.7 part, that's going to be your Thursday test. It's kind of backwards, sorry, but it is the way it is. Okay, so Thursday is going to be 1.7. It's also going to be discrete and continuous. Okay, it's also going to be about discrete and continuous. Can you tell me if this function is discrete or continuous? All right, so those should be easy ones. All right, look over them. They're not in a section. They're at the end of section 1.7, I think. Okay, so and then these right here. So here's what I want you to do. I want you to do the chapter review and the chapter test. Okay, now obviously for 1.7, the chapter reviews are easy because they're listed by section. It'll say 1.7. Okay, but on the chapter test, it's just all pushed together. So the part that you're doing for 1.7 on the chapter 1 chapter test is going to be numbers 22 through 27. Okay? On the chapter 2 test, which is going to be 2.1 through 2.3, you're going to do problems 1 through 11. Okay? So what I'm going to do back here with my book is I am going to leave a piece of paper. I'm going to leave a piece of paper where 1.7 is, and then the chapter test will be right behind it. And I will leave a piece of paper where the 2.1 starts, and you can just turn and flip. I suggest you take a picture of my book because then you have the answers and you know if you're doing it right. How many times do you have to do it? However many times it takes you to get good at it. Okay? Can you just be kind of good at it? No, because kind of good and a test and stress and pressure do not end well. All right? So, we're finished.